Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry will be helpful for international entrance examinations and competitive exams as well. And in addition to that one, JEE Advanced and JEE Mains for IIT and NIT examinations need chemistry for medical entrance examination. Telangana and Andhra Pradesh MSET for engineering stream, that is the technical domain. In addition to this one, if you are preparing for any government examination where you are aspiring for any kind of government organization career, so in that condition you are going to prepare for so many kind of corners of subject. So but whatever the subject you belongs to, general studies will be the common paper you can prepare for, where you can find a general science. The kind of session what we are discussing will be very much fetching towards that kind of preparation. Let's enter into our today's session. Question number 1, where explain the name of following compounds as per the IUPAC protocol. IUPAC denotes International Union for Pure and Applied Chemistry. IUPAC gave certain guidelines in order to give the name for different compounds. Here, certain functional groups are provided. Their classification is given. Suffix what we are using in a organic compound. If the same one is working like a substituent, then what will be the name of that? Entire things are explained in a detailed way. This entire table is given by IUPAC protocols. RCOOH is called higher priority. Here we are ascending towards higher priority. Carboxylic acid, where C double bond OH, which is called carboxylic acid. And according to this IUPAC, it is denoted as alkanoic acid. So oic acid will be the suffix. If it is a substituent, you have to mention carboxy. Whenever C double bond OR is there, that is called ester. Ester is called O8, alkanoate, right? So that alkanoate is substituent. Alkoxycarbonyl you have to mention as the substituent. If this is the main functional group, you have to go for alkanoate, right? So whenever you are going with C double bond NH2, C double bond NH2 is called amide. So all these are the part of what? Derivatives of carboxylic acid only. This amide, even in the IUPAC protocol, you can say alkanamide, right? So if this is the substituent, you have to say amido. Then RC triple bond N is called a nitrile. Even you can say alkane nitrile as per the IUPAC protocol. So if it is the main functional group, alkane nitrile can be taken. If it is the side chain, so that you have to mention cyano, right? So RC double bond H is called aldehyde. Whenever aldehyde is there, the suffix will be al, which is called alkanol. Alkanol, if the same aldehyde as the substituent, you have to mention formyl, right? So whenever you have RC double bond or, which is called ketone, RCOR is called a ketone. So whenever ketone is there, we have to mention alkanone. So whatever propanone, ethanone may not be possible. Propanone, butanone, like this, one will be the suffix. Okay, so if this oxygen, C double bond is the substituent, we have to mention oxo. Friend, ROH is called alcohol. OH, if present, called hydroxy. Then alcohol will be the name as per the IUPAC. Ol will be the suffix over there. And if OH is the substituent, you have to mention hydroxy, right? So RNH2 is called amine. This is called amine. So we have to mention alkanamine. This is called alkanamine. If NH2 is the substituent, we have to say amino. Amino will be there. So whenever R2C double bond C R2 will be there, carbon-carbon double bond is there, which is called alkene. So we have to say ene is the suffix, and alkene is, if this is a substituent, you have to mention alkene. Whenever triple bond designated as alkyne, ine will be the suffix, so that you can mention as the substituent alkyne. So if R is there, we can say alkane. Ane we can say saturated because of single bond. And alkyl, if it is a substituent, you have to say alkyl. ROR dash, which is called ether, right? So ROR prime, we can say ether. So alkoxy is the suffix. So alkoxy is the substituent name for this one, right? RX is called alkyl halide. For these alkyl halides, Halo will be the substituent name, halo, right? So this is the way we can go for the classification. All different functional groups are mentioned over there. IUPAC protocol is given. What is the name according to the classification? What is the suffix as per the IUPAC protocol? If this is the substituent, what we can pronounce, everything is mentioned over there. If you practice more examples without missing any single question, you can answer the IUPAC protocol more proficiently, right? Question number 1 is given for detailed explanation regarding the naming of these many compounds. Move on to question number 2. Farmers spread calcium hydroxide on their fields to neutralize soil that are too acidic for crops to grow well, right? If acidic soils are present in that, neutralization is required. So in order to neutralize, the compound added is calcium hydroxide. Which ions neutralizes the acid in the soil? What is the component which neutralizing from this one? Calcium hydroxide if you are adding, what is the neutralizing agent? Acidic soil mainly composed of H plus ions, right? Acidic soil is made up of H plus. In order to neutralize H plus, obviously OH minus is required. Combination of H plus and OH minus is called a neutralization. This is the way neutralization is carried. Let's see how can we explain. So soil is said to be acidic. Any soil is said to be acidic whose pH is in the range of pH 4 or else pH 4, 3, pH 4, 0, like this. Whenever pH is extremely low, less than 7, we can say the soil is acidic in nature, right? How can we test this one? Soil can be taken and its pH can be monitored. If pH is less than 7, you can identify it as acidic soil. Acidic soil is very good for some plants to grow, but bad for others. So that is not suitable to grow all kind of plant material in acidified soils. That's the reason why we have to examine the soil nature. Then only we can identify what is exactly required to grow the plants. Okay, pH scale is there, which is mentioned from 0 to 14. So 7 will be the in-between point, which is said to be a neutral point. Below 7, if the nature of soil will be, that is said to be acidic soil. If the soil nature is above 7, that is called alkaline, that means basic in nature, right? So what causes the ground to become acidic? So that is purely because of contamination with the surrounding regions, or else some minerals whichever present in the inside that one. Okay, so in nature, acidic soil is the norm when placed, including the most wooded areas. Mm, uh, so many regions, so many reasons are there in order to make the soil acidic. So that here a kind of contamination, acidified contaminative present, or industrial effluents if released, or else any kind of waste products dumped over there, or else minerals existing inside. All these are the factors in order to make the soil acidic. In order to neutralize, we are going to add calcium hydroxide. If calcium hydroxide is added with the any acidified soil, what it will do? OH minus released and H plus released, so that they become water, like this. This is the simple neutralization. You can see OH minus can be combined with H plus, so that neutral water will be generated. This is the neutralization of soil by the addition of alkaline substance to the acidified soil. This is the way we can neutralize. Okay, move on to question number 3, JEE Advanced 2020 question paper, paper 2. Oh, you collected this question. The figure below the plot of potential energy versus internuclear distance of hydrogen molecule. Its potential energy and internuclear distance got plotted, so that we got the curvature over there, and internuclear axis drawn over there. Here distance between two hydrogen atoms taken. Potential energy versus nuclear distance was taken over there, right? This is for what? Hydrogen molecule. In the electronic ground state, what is the value of net potential energy E naught indicated in the figure? Kilojoules per mole. D is equal to D naught, at which electron repulsions and nuclear repulsions energies are absent. Whenever electron repulsions are minimized and nuclear repulsions got minimized, all are absent, so that we can say D is equal to D naught. It is a condition where all the repulsive forces got minimized. As a reference, the potential energy of hydrogen atom is taken as zero when its electrons and the nucleus are infinitely far apart. Okay, so here potential energy is taken as zero, E naught. Potential energy taken as zero whenever electrons are far apart and nucleus interaction will be far apart. Both are infinite distance. Electron and nucleus are far apart, infinite distance, so that we can say potential energy with E naught, that is the reference compound. And Avogadro constant is provided, that is 6.023 10 to the power 23, right? So, this is the case. This is the case figured below, plot of potential, and this one is given in the electronic ground state. What is the value of net potential energy? Net potential energy is to be calculated. In order to calculate the net potential energy, so potential energy at this particular reference point, it is mentioned, but net potential energy need to be calculated. In order to make that, so potential energy is given by K into Q1, Q2 by R. K is the proportionality constant, Q1, Q2 are the values which are related with the potential energy, and R is the internuclear distance, radius we can say, and the K value is taken as, K is the constant, and this is for hydrogen atom, it is mentioned as 9 into 10 to the power 9. Okay, Q1, Q2 values are exactly equal, being it is hydrogen symmetrical, so that it will be 1.6 into 10 to the power negative 19 whole to the power 2, because Q1, Q2 both are equal, so both the values taken as the power 2, right? So, and radius of hydrogen atom is given as 0.529 into 10 to the power minus 10, being it is the ground state electronic configuration. So that radius is 0.529 into 10 to the power negative 10, right? So this is the case. If you see in the denominator, we have 10 to the power negative 10. If it goes up, what happens? The sign convention will become positive. So whenever 10 to the power 10, it is coming to the numerator, what happens? 9 plus 10, it will become 19. Plus 19 it will be. Plus 19 minus 19 get cancelled completely. But here 10 to the power negative 19 we have taken twice. So that 10 to the power minus 19 will be cancelled with them, and another will left like this, 10 to the power negative 19. Only one is left because another one is cancelled with them. Right. So 9 remains as such. 1.6 taken square, no. So that let me mention twice. 1.6 multiplied with 1.6. In the denominator, we have the value 0.529. So that will be taken as such. Total potential energy, being we are taking for Q1, Q2, two hydrogen atoms mentioned over there. That's the reason why two hydrogen atoms mentioned over there, so that whatever value coming can be multiplied with 2. 2 can be multiplied with 9 and 1.6, 1.6. And the denominator radius value will be 0.529. Okay, so in order to get the net potential value, we have to multiply with the Avogadro number. Avogadro number given in the data, 6.023 into 10 to the power 23. So if you go for the calculation of these entire terms, for net potential energy, that will be negative 5246.5 kilojoules per mole. That is a value which is given in the problem. 5246.5 kilojoules per mole is the correct answer, right? So this is the question related with the potential energy, internal energy, atomic structure part. It will be purely, it is atomic structure part. For question number 3, answer will be negative 5246.5 kilojoules per mole. Move on to question number 4. It is the part of what organic chemistry and related with the numerical. That means mathematical part is applicable in the organic chemistry, so that we have to go for how to solve the equation and how to solve the problem as well, right? Consider the reaction sequence starting from pre and ended with a Q. The overall yield of the major product is taken as Q and started with P, but P if taken 100%, from the 75% got reacted, not 100% reaction. 75% P if reacted, we will get the yield with the major product Q, right? So what is the amount of grams of Q obtained from 9.3 ml of P? If starting material taken 9.3 ml, And that 9.3 ml not completely reacted, rather 75% only reacted. So from that, what extent of Q will be generated? Okay, density, because here volume is given, asking for grams. So that volume must be converted into grams. So already we know the formula relation between the volume and volume and weight. That is the density is equal to mass by volume. We can convert mass into volume, volume into mass by using this formula. So that they mentioned the density. Density rho is equal to 1 gram. Molar mass of the carbon is 12, hydrogen is 1, oxygen is 16, nitrogen is 14. This is the way entire elemental atomic masses are provided. Density is also there. It is obvious to calculate amount in grams. Initially, the starting material P, it is named as aniline. Whenever aniline was taken, that is treated with NaNO2 HCl at 0 to 5 degrees centigrade, this is called a diazotization. Mixture of sodium nitrite and hydrochloric acid used to generate nitrous acid in situ. Nitrous acid can't be stored in the laboratory, being it is highly reactive and can participate in atmospheric oxidation, immediately converted into nitric acid. That's why in order to synthesize nitrous acid, we have to mix up NaNO2 and HCl within the reaction mixture. Within the reaction mixture, we need to carry the reaction at 0 to 5 degrees. Then only nitrous acid will be synthesized within the reaction vessel. That nitrous acid can be reacted with this aniline, so that aniline will be converted into benzene diazonium chloride. The benzene diazonium chloride will suitably react with the any alcoholic compound or amine compound. These are called ring active compounds. Only these two will be suitable for this one. Hydroxy, aromatic ring with hydroxy, or else aromatic ring with NH2. They will participate in coupling reaction. The name is coupling reaction. Paraposition reaction is possible with them. So whenever this reaction is possible, we will get a coupled product. And further, we will go with CH3COOH. That will be treated with protonation. This is a kind of mild acid. Acetic acid is the mild acid, aqueous. That means we can say aqueous acetic acid. Acetic acid can be taken in glacial acetic acid form. Acetic acid, aqueous acetic acid can be taken. So here aqueous acetic acid will be added so that we can protonate. Protonation will be possible over there, right? So finally we will get the product, which is the kind of condensed molecule. So that coupled product will be generated. That product amount we need to identify. So yield we know. So how much starting material reacted we know. How much amount of product we are generating, that to be calculated. To get that one, first of all we have to go for series of reactions. The starting material is aniline. Benzene connected with NH2 is called aniline. NaNO2 with HCl, this is called sodium nitrite with hydrochloric acid at extremely low temperature called 0 to 5 degrees used to make diazotization. We can say azo dye. This is the azo dye. This benzene diazonium chloride will react with what is this? 2-naphthol or beta-naphthol. This is called beta-naphthol. Whenever it is treated with beta-naphthol, it immediately participates in coupling reaction. This is called what? Coupling reaction. This is an intensified colored compound. So this is the intense colored compound we can use for coloring of cloths, dyeing of cloths, right? So this compound further treated with aqueous acetic acid. Whenever aqueous acetic acid is added, whatever O minus is there, that will be protonated. This is the protonating agent. So that whatever compound we got, benzene diazonium coupled product of beta naphthol, right? So this is called a dye, azo dye we can say, right? So the final product amount we need to calculate in order to make that P molar mass. P is the aniline, no? So being it is the aniline, you have to calculate its molecular weight. Molecular weight is calculated as 93 grams. Then if molar mass is known to you, number of moles is obvious to be calculated. Number of moles is equal to weight by gram molecular weight. Weight of this P can be taken as 9.3 ml, right? 9.3 ml can be taken. So for example, 9.3 ml will be given. You have to convert into what? Grams. How can we convert ml into weight? Ml into amount? That means volume into weight. Density is equal to mass by volume. Then mass is equal to density into volume. Here, density is provided as density of P is 1 gram only, no? So that you can multiply with 1 ml. 1. So that 9.3 into 1, so that it will become its grams. Ml within the problem they mentioned with milliliters, and it became grams by multiplying with 1, being density is 1. Okay. So moles is equal to weight by gram molecular weight. 9.3 by 93 grams, so that it will become 0.1 moles. 0.1 moles of what? Aniline you got. So that the extent of P reacted, the extent of what generated? Q generated. Q means end product. The final product what you are preparing here. So that it's a number of moles. It's a number of moles to be calculated as a 0.1 only, because how many moles you are reacting, those many moles of product will be generated. And this benzene azodide product molar mass is calculated as 249 grams. 249 grams. If its weight, its molecular weight is known to you, number of moles also known to you, it is obvious to calculate what its amount, what they are asking for, what is the amount of Q. That amount of Q can be calculated, mass of Q can be calculated by multiplying with number of moles with the molecular weight, and this is 0.75. Why we are taking 0.75? Whatever P starting material was taken, it is reacted only 75 percentage. 75 by 100, it will become 0.75. Okay, so that number of moles of Q, molecular weight of Q, and 75% means 75 by 100. This is the all the product of these three numerals will become mass of Q. After the calculation, you will get 18.60 grams. 18.60 is the weight of Q, amount of Q. So this is the way you can go for the calculation. In order to make the calculation, first of all, we have to understand what is the role of the reagent upon the starting material. These many series of reactions, what is the expected product over here? After getting expected product, what about the calculation of yield? So everything we need to identify, we need to understand, then only we can solve the problem. For question number 4, 18.60 grams will be the correct answer. Move on to question number 5. It is collected from Telangana Gurukulam Degree College Lecturer Entrance Examination. Which among the following is the correct statement? This is the question given from organic chemistry, stereochemistry, conformational isomerism, right? The board conformation of cyclohexane is about 6.9 kilocalories per mole higher in energy than chair form. Okay. So in order to explain this correct one, first of all, we have to see what is meant by conformational isomerism. What is the conformational isomers? What are the conformational isomers of cyclohexane? And what will be the order of stability? How can they differ by this energy? Right. What is meant by conformation? Conformation denotes what? Whenever carbon-carbon single bond is there in the compound, then only conformational isomerism is applicable. Carbon-carbon double bond, triple bond will not favor for this one. Only saturated compound, internuclear axis of carbon-carbon single bond having possibility of rotation like this. Carbon-carbon single bond rotation if possible, spatial arrangement of one of the carbon functional groups got entirely changed by rotating the one of the carbon atom, so that we can experience a new orientation of existing functional group. All these are said to be conformational isomerism, conformational isomers, and the process is said to be conformational isomerism, right? So if you are taking cyclohexane exists either in the chair form. This is called pest board. This is called a board form. This is called a half chair. So these many possibilities, if you are going to flip, if you are going to rotate carbon-carbon bond, in one of the condition it exists in chair, and in either condition pest board, and next is about boat exactly, and this is called a half chair. Okay, if these two are possible, these two conformers are possible for cyclohexane, this is called energy minima, minimum energy, maximum stability. And if you are going for these two conformers, energy maxima, maximum the energy, minimum the stability. This is the way chair conformation, the energy is provided with zero. That's the reason why it is more preferable conformer for the cyclohexane. And the next level will be twist boat with the energy of 5.5 kilocalories and boat having 6.9. Half chair is having 10 kilocalories per mole, extremely larger energy, extremely unfavorable condition. If you go with the boat conformation 6.5, that point only they mentioned. Boat conformer of cyclohexene is about 6.9 kilocalories higher compared to chair. Chair is having 0, boat is having 6.9. So that the difference energy is 6.9 kilocalories. So that it is more stable. Chair conformer is more stable. That point mentioned over there in the point number 2. Right. And here stability order is mentioned in the graphical representation. Chair is at the bottom position, least energy, higher stability. Half chair is moving up, so that higher energy, least stability. Twist boat is somewhat lower energy, we can say. Compared to twist boat, boat is having somewhat higher energy. Twist boat again coming down, dropping down. And if you go with the half chair, again extremely higher energy, you can notice about 10 kilocalories per mole, you can say. And least will be chair. Chair forms are highly stable forms. This is the way we can, this graphical representation clearly mentions the energy barrier, energy profile of all conformers of cyclohexane. And the last question of the session, again it is the part of organic chemistry, we can say it is the part of photochemistry, right? The correct starting material for the synthesis of following target molecule, right? This is the product. In order to synthesize this product, what starting materials we have to utilize? In order to make this product, the starting materials must be, one is diene, in either dienophile. Diene-dienophile combination is called a Diels-Alder reaction, so that the product will be generated. In order to make that, here detailed mechanism is provided. This is called diene with the double bond conjugation, and here another double bond, so that they get cyclized. So one of the compound is having two carbons with a double bond, so that we can say, so here two electrons, 2 pi electrons are there, and the second compound is having 4 pi electrons. Here one double bond indicates 2 pi electrons, here 2 pi electrons, so that 2 plus 4 cycloaddition, 2 plus 4 cycloaddition is called what? Diels-Alder reaction. One of the double bond is forming a new bond between these two. This pi bond is delocalized over there, new sigma bond will be generated, and this pi bond is delocalized, so that all are going to combine to form a cyclic 6-membered ring like this, and whatever substituents are there, they are moving towards the VR, so that wedge bonds are provided. So this is the way we can represent the final product, which is formed from the starting material. One is a double bond with COOET, another with the diene conformation, diene kind of representation. This is called Diels-Alder reaction. By this, we entirely covered the concepts related with the various competitive examinations, various already existed competitive exams we considered, and we retrieved the concept from that domain, and various corners of chemistry also mentioned over there. A kind of reaction mechanism mentioned, stereochemistry part is also covered over there, physical chemistry part, problem solving, analogy, everything. So many kind of dimensions we look after. I am sincerely requesting to like the channel, comment which is important for your preparation, and share with the aspirants who are serious for the competitive exams and entrance examination, and subscribe the channel to receive more such updates in the near future. Thank you very much for your patient listening. Thank you one and all.